we have acids, bases, and salts. Now, in real life, there's a whole bunch more. If you go on and take organic chemistry, you're going to hear about aldehydes and ketones and carboxylic acids and on and on. And if you take biochemistry, you're going to hear about nucleic acids and DNA and RNA, amino acids, proteins, and the list goes on and on and on. But here, to simplify your lives in general chemistry, almost exclusively we deal with acids, bases, and salts. Occasionally something else slips in, but it's these three things. Now, how do we define an acid? This is the original definition, sometimes called the classical definition, or also the Arrhenius definition, and it's a substance with H in the formula, and it produces a hydrogen ion in water solution. Now, if you go on and take 1412 or more chemistry, there have been other definitions of acids over the years. So this is the original one. Can anybody think of an acid that you've worked with in the laboratory? Hydrochloric. Marco, do you know the formula? HCl. And to truly be an acid, you've got to write AQ behind it. It's got to be an aqueous solution, because this is part of the definition. You get these hydrogen ions in water solution. So the first skill I want you to get from this section is, if I write a formula, you can tell me, is it an acid, a base, or a salt? And you're just going to look for that H up front. There is no way for you to know, is this really going to happen in water? We're just going to assume it would. We'd actually have to go to the lab to measure that. So, H up front. And that's the acid, your stomach acid or gastric acid, that's hydrochloric. Does anybody know another acid that we've worked with in the lab?
Oh, hydroiodic.
Okay. Okay, we haven't worked with it in the lab, but do you know the formula?
HI, aqueous.
HI, aqueous solution. That's another one. We recognize it because of the H out front. Okay, now there are organic acids. And when a chemist says organic, it's got nothing to do with what the health food store people think or say. When somebody in a health food store says this is organic, they mean it's grown without pesticides and so forth. We mean it's got carbon and hydrogen in it. This is acetic acid, and it's the active ingredient in vinegar. And an organic acid, you always see this CO2H unit, usually at the back of it. It may have one of these, it may have two of them. But that's what you look for, but the H is in the back. It's got to be a CO2H unit. Something like this doesn't cut it. That doesn't cut it. It's got to be that unit. And if you go on to organic, that's called a carboxylic acid, is the broad category. What's that? You need to recognize, you don't need a name for it, but you've got to recognize, yeah, that's an acid. Most of these organic acids have very distinctive odors, like vinegar. You know what vinegar smells like. That's from this acetic acid. And you can have more carbons on the chain. If you have, let's see, it's 4 carbons on the chain, and then it ends up the O2H business, it's the smell of rancid butter, or butter gone bad. And I think now they put so many preservatives in butter that it never happens, so nobody ever smells that anymore. If you have 6 in a chain, it has the odor of goat sweat. In fact, that's how they discovered it. I don't know what chemist would have a goat on a treadmill, you know, collecting dirt, collecting sweat, but in goat sweat, they find a carboxylic acid that gives the goat its distinctive odor, and instead of just having 2 carbons, it's got a total of 6. And have I told you how dogs track people? I don't think I've told this class. Okay. When dogs track people, if you have a child that's lost, or you have somebody that's escaped from prison, they put the dogs out to trail it. But to do that, the dog first has to sniff some clothing or a blanket or something. The theory is, in everybody's perspiration, we have our own little unique combo of carboxylic acids. That's what the odor is. And different people have differing amounts of the various size carboxylic acids. So the dog keys in on, hey, this is what you smell like. And these folks smell differently. And so the dog sniffs the clothes and goes out chasing the person down. And sometimes they find them and sometimes they don't, because if the person goes through water, goes through a river or something, then you're going to wash the perspiration away. But it's interesting because what kind of dogs do they use? Usually the dogs with the great big ears and the really wrinkly faces. Why those are good dogs for tracking? Because as they're running along, the great big ears collect air molecules, okay, and the big wrinkly face collects it and funnels it to the nose. So they're going along, like this. If your dog had had a big facelift, he would be worthless as a tracker, or not as effective, because he doesn't have all those wrinkles and big ears. So if he's had his ears done or something, he's not going to be as effective. And I've read that a dog, I don't know how they would prove this, could pick up like one molecule like over a mile distance. So they can track over a long, long distance. So anyway.